That may be better. Good morning, everyone, or good evening. I see a few of my colleagues from Western Sydney here. I'm Don Shearman, and my colleague Jim Pettigrew is also here and will be chiming in as we progress through the talk. At Western Sydney University, we've started using numbers in a big way, I think, in the last 12 months. For the obvious reasons, although we had been looking at it before that. A little bit about us. Western Sydney University is a university of about 45 to 50,000 undergraduate students plus postgrads. We're a multi-campus university spread across 11 campuses across the greater Western Sydney region. And some of you may have seen a map that I've put up at a couple of Kettle MSOR conferences that I've spoken at recently about the geographical area that covers. It's quite a large area. The Mathematics Education Support Hub is the team that provides math support across those campuses. There are 7 of us in the team, making up about just over 5 full-time equivalent people. So we're very fortunate to have a team of that size. But of course, we do have a lot of area to cover. And as COVID has hit, we, like everybody else, became locked down and had to provide all of our support online. So the use of some sort of a testing facility beyond what Blackboard could provide us was obviously an essential thing for us to be able to use. Jim, did you have anything else to add? Have I missed anything? Please jump in if I do.
No, we're good at this stage. Maybe one thing to add is that we, as a sort of a central learning support unit, we connect with many different schools. So we're sort of working with the quantitative sciences across the board, from engineering, maths, business statistics, right through to nursing numeracy.
Yeah, thanks, which very well brings on this next slide. In the about 6 months since we've installed an LTI server so that we could integrate numbers with our Blackboard system, we've got, I actually looked on the server today, I think 189 assessments available. But what we've written them for has been a lot of support things. MathStart, which we used to offer as a face-to-face refresher workshop at the beginning of the academic year, had to be rewritten last year to be presented fully online. And as part of that, we wrote around 90 formative assessments plus summative assessments for students to test their understanding of the content. And as you can see, that was algebra, trigonometry, calculus, and statistics. As Jim mentioned, we've just been assisting nursing in running some of their diagnostic and nursing numeracy tests for the system this semester. We've also written or translated a basic maths test for programming fundamentals into numbers. We've had one of our main units with the head of MESH, Professor Leanne Ryle, Associate Professor Leanne Rylance, who's I saw with us today, has started using it for summative assessment in her discrete maths unit. Another one of our colleagues is writing quite a few questions for our education students who have to pass a hurdle test in numeracy before they're allowed to go out and teach. So we're making quite broad use of the system. And what we want to talk about today are some of the features that we've found particularly useful, some of the pitfalls that we've met and the ways that we've overcome some of those, and a couple of the shortcomings which we see as being things that are being improved almost daily in the process. So in selling numbers to our technology-enabled learning group to enable us to integrate it with with our Blackboard system and get our LTI server. These were some of the benefits that we saw of Numbers. Firstly, it's free, which I think impressed them, particularly last year when budgets were so tight for universities. Anything that was going to improve teaching and wasn't going to cost was certainly beneficial. I'm probably preaching to the converted here with all of these other things, so maybe I can just give you a minute to read them. Jim, were there any that you wanted to highlight?
Oh, I think the first one's actually significant when you consider that, you know, there are schools that are still using e-assessment, commercial e-assessment systems that cost X dollars per student, you know, to license. And, you know, X can be quite large. And the total can be quite large when you consider that X would be multiplied by 1,500, 2,000 for some of the high enrollment units that are using these systems. So, yeah, so there's a sort of a fairly significant cost saving, I would say, in using a system like this. And that there's cost savings at the other end as well. But that's probably separate to this, but one benefit it might have not been explicitly mentioned here is just the cost saving in terms of marking. So, you know, we've seen that happen in a major first year clinical nursing unit that is now using Numbers for its numeracy testing, as Don said. So their enrolments are very high, you know, by Western Sydney standards, up to 1,300, 1,500 students who would have been completing pen and paper tests and having them marked by a whole battery of human beings. They have now, at least for one or two of the three numeracy tests they ran this session, they're now, you know, being done by a robot. So, you know, you do the maths on that. Don and I did the maths briefly, and we were north of $10,000 saved.
And of course, there's also a lot of benefits in the LTI server in terms of the data that we can collect for each assessment, or for each attempt at each assessment, and for review when things, or if things go wrong. And we've certainly made some use of that this year. What we mainly wanted to show you today were some of the questions that we've written, the way that we've used this system to write questions which are a little bit novel, certainly different from the kind of things that could be done. As I said, previous to this, all that we had was the Blackboard testing system, which is pretty diabolical. And as Jim mentioned, in terms of cost, our MathStart Blackboard site, which is for our refresher programs, has every student in the university enrolled. So there's about 70,000 students in that. If we were paying for commercial software for that, I don't think we'd be doing it this way. So this was a question that we've used in MathStart, one of our algebra sections, where we want students to add surds, subtract, work with surds. And of course, the thing that you want with these sort of questions is for the students to reduce the surd at the end. So we don't want 3 root 2 plus root 50 minus root 32 for the student to just write that in as the answer, which Numbers would accept and mark as correct because it's mathematically equivalent. But with the pattern matching system that's in Numbers, we were able to nail that down. And I'll show you how we did that here. So this was the question. And of course, it's randomized. We're using quite a bit of randomization through all of the questions. The new restriction system allowed us to write this. Perhaps this is one of the shortcomings of the system. It took us a few hours, I think, to come up with this pattern matching from the documentation. But basically what we're saying here is that the answer has to be a number, which may be positive or negative, and that number is not equal to plus or minus 1, not equal to 0. And it may be there or it may not be. So the answer may not include a number, but if it does include a number, it has to be a number that's not plus or minus 1 or 0. And then plus or minus the square root of a number. But we needed more than that. We needed to be able to nail this down so that the thing under the square root was square free. And to do that, we used a little bit of JME. Basically, what we've done is to factorize the number and then filter out the factorized function in JME presents or gives the indices of each of the primes up to and including the largest prime that's a factor of the number. So we extract any of those. We look at those that are less than 2, the indices that are less than 2. In other words, they're 0 or 1. And if that filtering the factorized string or the factorized string is the same as factorizing the number, then it's square free, and therefore we admit the number. So it was a little bit of a roundabout way to get there, but it's given us exactly what we want. And the alternative is, of course, that the answer is 0. So that was one way that we were able to write something that's a little more directed than could have been done in other systems, and provides a little more benefit to the students. Jim, did you have anything else on that?
Oh yeah, I'll just say that it's just a general reflection on pattern matching. I don't think, Christian, this is regular expressions, is it? It's something a bit different to regular expressions. Yeah, but anyway, this and similar systems involving regular expressions, they're often capturing things that are quite easy to state, but they're very difficult to sort of capture, to write down, in terms of the logic. So it's just a reflection. Regular expressions, in my view, can get pretty messy and pretty kind of arcane pretty quickly. Like this, I would say. I mean, it's very easy to say what you wanted. You could say it in one sentence, but it took you some time to actually nail down the logic.
Yeah, and to work my way through the JME to find the right functions. But it's a learning curve. Another question that we're quite proud of, and this is one that Jim put a lot of time in, is using the interaction with GeoGebra. Normally in nursing numeracy, students would be asked a question, they'd be given a picture of a syringe with a line marked on it and say, what's the dosage here? What amount has been drawn up in this syringe? But with this question, Jim's been able to, in GeoGebra, and I hate to ask how much time he spent doing this, to do a pretty reasonable facsimile of a syringe, which is movable. So in this case, the student's being asked to draw up a dosage, 0.92 mils. And when we submit the answer, the feedback comes from reading into GeoGebra, or reading from GeoGebra. It's actually the position of this blue dot, and then a little bit of work in the marking algorithm, which is here, to calculate whether that equates with the amount that the students were told to draw up. And of course, again, it's all randomized, so it's a far more practical question than the sort of thing that students would be asked normally, well, even in a paper-based test, or in any other sort of online quiz. So we've used GeoGebra a fair bit. There's another question here that uses it as well, and we've found it very good for developing new types of questions and new ways of asking old types of questions. Another one that I came up with was, instead of asking students or giving students a multiple choice question, just give them one of the answers. And again, this was a question that we wrote for nursing. So the student then has to check their colleagues' calculations, which is something that they're supposed to do on the ward when they're working. But the other thing that I did with this was, rather than just making it yes, no, and randomly choosing 4 from 3 or 4 other answers, I've set this up so that there are 4 answers, which are set up as the most commonly, well, the correct answer and the most commonly calculated errors. But to calculate which one, I've set up another variable called probability, which is a random variable between 0 and 1. And if that number is, in this case, less than 0.4, then it gives the correct answer. So it means that 40% of the time the question will give the correct answer. And then for the other 60%, it'll give one of the 3 other answers. So you can build this system where the proportion of time that yes is correct is not random, or sorry, is not something that's easily guessable. And I was thinking of this the other day, and I could replace this 0.4, 0.6, and 0.8 with 3 more random variables, so that the probability of the answer being correct varies from question to question, which would make it even harder for students to guess where they were going. So again, it's a nice way of presenting a question which is different to what's normally being done, and a different way of testing what the students are doing. And by the way, all of these questions are published. So, and these links in the presentation are links to the questions. So if anybody wants to have a look at them after the presentation, you can do that. The other thing that, again, with our elementary algebra, one of the things that so often happens in maths questions is that the variable is called x. And that's all that students seem to get. I wrote this question wanting to have different variable names within the question. So not only are the numbers in this question variable, but so are the variable names. So they're chosen at random from a list of variables. I have a number of pronumerals, including a blank, so that this question can have constants as well as variables. We shuffle that, choose the first 2 of them, and use those as the pronumerals in the question. It took a little bit of extra work writing the advice for this to get it to work, but I think it gave us even more variability. I think this question, if you take all of these variable combinations into account, there's about 120,000 possible variations on this one question, which means that students, in a formative sense, when they're doing this as a formative assessment, are going to get a lot of different questions. Their chances of getting the same thing twice are virtually nil. And the last one that we're going to show you, this was one that we had to enlist Christian's help with to get the things working. This question again uses GeoGebra. So we use GeoGebra to graph a trig function, either a sine nx or a cos nx. And we're asking the student to find the amplitude and the period. The problem that we had with this was that the expected answer, if the period wasn't an integer multiple of pi, the expected answer, came up as a decimal. And of course, we wanted to show it to the students as a fraction of pi. If the students entered the answer as a fraction of pi and it was correct, it marked them as correct, but we also wanted it to display it that way. And what we found with that one was that we had to modify the answer in the gap. I think I may have pulled up the wrong question here because it should be ANS period times pi. But we had to explicitly put the times pi into the answer to get it to display the way that we have it here when it's a fraction of pi. So that was another trick that we had to work out and figure our way around. Jim, anything else on those that you wanted to throw in? You probably should.
No, that's good. Yep, I think we're, yep.
Oh, I just need to go back up.
We missed.
So, as we said, we find numbers excellent. It does have a few challenges. The documentation is something that's in development and something that we had hoped to be able to contribute to this year, and we're certainly something that we'd like to do. We find that a lot of the advanced documentation is great when you understand what it's doing, but to learn it for the first time, it takes quite a bit of effort and time to get there. We've had a couple of glitches in the LTI integration, which I'm going to be talking to Christian about, but they've been very minimal, and on the whole, even with students who don't click the submit button when they're doing the test, we're still able to capture their answers and grade them, which is great. The only other shortcoming we see is, whilst there are a couple of people at Newcastle running this, Christian is very central to it, and we still have a relatively small user community, which I'm guessing is growing fairly rapidly, and we hope will do, but it is a slight limitation. So going back to our original question, is numbers the best thing since sliced bread? Well, thinking back to sliced bread is something that's a one size fits all. You get one size of slice no matter what size the loaf is. So in some senses, numbers is a hell of a lot better than sliced bread because we can make it do a lot more things. It has much more flexibility. It still has some things to improve, but overall it's something that we've been very happy with. We're glad that we made the move to it, and we're starting to get quite a large user community at our university that's using it. So I'll stop there, and thank you very much. And we're happy to deal with questions if anyone has any.
Yeah, there are questions. So thank you for your interesting talk. There are 3 questions in the forum. I don't know if Christian wants to speak out for himself, or I should read his question.
I'm typing an answer to one of the questions. I think Don and Jim should answer anything first, and then I'm also here.
The most difficult topic we've successfully used numbers for. One of our colleagues at the moment is writing some questions for a 3rd year statistics course using text mining. We're working on that at the moment. We're working with another colleague from one of the schools who's writing some questions in thermodynamics. But the vast majority of what we've done so far has been fairly basic mathematics. The numbers, the math start goes up to introductory calculus. So we've done some basic calculus questions, but that's about as far so far. But I know there's lots of other stuff out there that people are.
Well, one of my inspirations, I've never met him, but he's in the numbers forum. I think his name's William Haynes, and he teaches engineering within a maritime college in the States. And you probably know him, Christian. He's quite an advanced user, and I've sort of copied and picked apart a lot of his questions. And he has some beautiful graphics of, for example, excavators, that might be on a sledge or something, and there's all these moving parts, and there's moment arms, and it's very complex. So it's quite inspiring, actually. And I know that at UNSW,
sorry, Jim.
Yeah, at UNSW, we have colleagues who are using it for linear algebra and other more pure, I guess you would say, applications, so to speak.
There's a very nice question in there that's been written on applying Dijkstra's algorithm to a graph, which
Yeah.
I think the writer of that said it took him the best part of a week to write it, but it's certainly a beautiful question. Christian's question on pattern matching. What would make pattern matching easier to write? It's just getting around the notation, I think, and understanding what each of those things does. I mean, certainly a number not one or a function that's square free would have worked in this example, but if we go on and do it in something else, we're going to meet other challenges of how do we express it. And maybe it's just more examples in the documentation that's going to make that easier for people. And perhaps what we should be doing is taking things like this and giving them back to you to include in that document.
There is an element of it that's just hard, though. I mean, I know, programming students, in Stack Overflow, they're always asking about regular expressions. It's always difficult for them. I just think there's part of it. I mean, it's straightforward if you're just saying, I want a number between 0 and 9, I want a digit between 0 and 9, or, I want something alphanumeric. But if you're wanting an email address that contains this but doesn't contain that, and it's, in some HTML element, then it's necessarily going to get more and more difficult as you get more and more specific about what you want.
Okay, I'm aware it's nearly 9:30 over there. Do you want us to stop and answer the rest of these questions in the chat, in the questions, or do we have time to?
For one more, I think.
Okay, the next one I've got here is about high stakes assessments. Did we use a lockdown browser? Unfortunately not, because that assessment was being done remotely, and there's a whole issue of academic integrity and assessment, which we're actually going to be addressing or discussing next week at our first year in maths forum that's going to be held online on Thursday and Friday of next week. I mean, the precaution-wise, we used Zoom during those sessions to monitor the students, but that was about all that was done with those. We're still looking for good ways to assess students. In fact, this semester at WSU, one of my units, we brought the students back onto campus to do the assessment.
Okay. Yeah, thank you very much again for your interesting insight.
A pleasure.
Thank you.
And yeah, thank you. Look forward to some more questions, and we'll answer those ones in the chat.
That would be great. Thank you.